So here I am back at my problem. And from the picture that I drew, I'm thinking that this linear function minus pi of sine of pi halves times the linear polynomial x minus a half divided by, well, I'll call this negative x minus a half. Excuse me, there's a typo there. Well, if I were allowed to do that, then I know I could then just cancel those zeros, right? Cancel those common factors the same way as we did when we were first learning limits. So when you zoom in close enough, the function basically looks like it's 0. The function basically looks like it's a line because it's differentiable. So maybe I could do something like this and say what I've got is a slope, excuse me, my limiting value should be positive pi. Is that actually justified? Well, let's go back to the graph. I will look at my original two functions again. So in red, I've got cosine of pi x. In blue, I've got minus x plus a half. And, you know, I could just graph the quotient of these two things. Cosine of pi x all divided by minus x plus 1/2. And so here it is in purple, the graph of that quotient. And I'm expecting it to have a hole here at x equals positive 1/2. But again, Desmos does not show us the holes by itself. But notice that it limits to, well, okay, this is in fact undefined if I get Desmos to point itself right at that point. But this is close to pi, just like my guess said it would be. So this idea that maybe in certain circumstances, we can replace the function by its tangent line instead to calculate the derivative. This has some merit to it. So this is a special technique called L'Hopital's rule. And what I'm going to do next is I'm going to, well, I'll explain this rule in practical terms, but also explain why it is that it works in the situations that it does.